Hello everyone and welcome to the Quiz 2 revision session of CMPS 201 presented to you by the Cultural Club of the South. I am Muhammad Al-Alami, a junior computer science student. So let's get started. Question 1, we have write a Java method which is expand and analyze that takes a square 2D integer array and returns a new 2D array that adds one extra row and one extra column. Okay, so we have a 2D array which is a square, so n by n. It returns another 2D array which is n plus 1 and n plus 1. So your method must copy all elements of the original array into the top left part of the new array. Okay, the extra column must contain the sum of each row, and the extra row must contain the maximum element of each column. And the bottom right corner must contain the sum of all rows, so the sum of the entire original array. So let's get started here with VS Code. So question 1 dot Java, we have public class Q1 and public static void main string args. Of course, I will copy this as is. Okay, so first of all, we should copy all elements of the original array into the top left part of the array. So I will start with int n equal the array dot length since I will be using it in this method. Okay, so we need first of all to have the thing that we will return. So int result, for example, um, it is a 2D array. It is equal to a new int, and the size is n plus 1 and n plus 1. Okay, so we'll start off with copying the original array. So for int I equals 0, I less than n, I plus plus, and same thing for int j equals 0, j less than n, and j plus plus. We do the following. We do array at I, and we want to copy it to the result at I. So result at I equal array at I. This is for the column, for the row, and we need every set. So ij equal array ij. So this right here copies the original array to the result array, but we still have the last column and the last row empty. So the last column we should contain the sum of each row. So here for int, actually I'll copy the nested loops from above. For int I equals 0, I less than n, and for int j less than j equals 0, j less than n, j plus plus, we are calculating the row sum. So I will add here an integer row sum that every complete loop restarts to 0. So every inner loop here, it will restart to 0. And here it is being incremented by result at I, j. So here what is happening is we are looping over that row, and we are adding every single cell in it, and we are storing it in row sum. After this happens, we should have here result at I and n equal to the row sum. And to be noted here that the bottom right corner must contain the sum of all rows. So since we are doing that sum right here, we can do like the same idea, int total sum equal to 0. And here, after we finish calculating the row sum, we have total sum plus equal row sum. And after we finish all that, we have um, result at n n equal to the total sum. And so what we have done here is we finished 1, 2, and 4. So we still have 3 to do. Okay, so they need an extra row to contain the maximum element of each column. So as usual, the double for loop, I will paste it again. But we should be careful that we want the maximum element of each column. So we are looping a column by column. So uh, the loop should be something like that. This tells us the column is the same and you are looping over it by changing the row. So we need the maximum. We know from previous solving that we need to save it and to store it and to compare with it. So int max equal, it can be the initial value. So result at 0, so row 0 and the column I. And here, so we can start looping from 1 and we compare with this maximum. So if result at ji is more than that maximum, we need to update the maximum. So max equal result at ji. Okay, so and here, of course, every loop this gets reset. Um, and this is pretty much it. We should do one more thing, which is before returning. Let me write that return the actual to the array. But before that, after we calculate the maximum, we should store it in the array. So result uh, at the last row, since we need the last row, so n, and the column is I equal to the maximum. Okay, I will paste here a driver I have done before. So here it is. And I will try running it to see if everything is as intended. Okay, so here I press run main. Okay, so here it is. As we can see, 426751389. It is copied as intended. Here we have the sum of every row, and here we have the sum of the sums, and here we have the maximum of every column. So this is question one for you. Let's go into question two. Question two, we have write a Java program that reads words from a file named words.txt. This is words.txt. You have one word per line. And your program must store all words in an array list string only if they are not found previously. Write the resulting unique words into a new file named unique.txt one per line. So the first step is to read from words.txt and store them in an array list of strings. Um, and of course, they are not found previously, so we do not have duplicates. And the second part is to write to unique.text from that array list we have. So here we have the everything set up. So let's get started with creating the empty array list of strings. So array list string, let's call it list equal new array list. Of course, when we have an array list, we should import java.util. Okay, so now we want to read from the file words.txt. So file uh, f equal new file. Let's call it the words.txt. Of course, one more time, we should import java.io for opening a file. Then after that, we want to use the scanner to read from that file. So scanner equal new scanner, and we pass down, usually here we pass down the keyboard system.in, but since we are reading from a file, we pass down the file, which is f. After that, what we need to do now is to read from the file. And usually, when reading from a file, we do not know um, how many words are there. So we do a while loop. While what? We can do while n dot, since we are reading a word by word. So while n dot has next. What are we doing? Has next, we have to read the every word by word. So string word equal n dot next. Okay. And then we should store that word in the array list only if it was not previously found in the array list already. So if list, okay, so here we want to add if it was not found. So if list dot contains does not contain. If list does not contain f, what are we supposed not f word? If list doesn't contain the word, we should do one thing, which is add it to this list. So list dot add word. Okay. This thing is it shows an error right here. So we should add throws file not found exception. Okay. So in this way, we are ensuring we have no duplicates. And after the while loop ends, we have this guarantees that we read all the file and everything was added to the list. So after that, we should now print to the unique.txt file as shown right here. So we print or write to a file using print stream. So print stream, we usually call it out, like system.out.print. So out equal new print stream, and I will give it the name unique.txt as required. So after that, I will loop over the words in the array list and print them out or write them in the unique.txt file. So I will use the enhanced loop for string word in list. What shall I do? Out dot print the actual word. But here, as you can see, they are telling us one per line. So out dot print len the word. And in this way, we print every single word on a new line in the txt unique.txt file. So after that, I will add a print statement. So system that out of println done just for something visual to show on the terminal. So after I run right here, we see done. I open the file explorer. I see unique.txt. And here we have apple, banana, orange, kiwi, grape, mango, and pear. The expected.txt here also shows us the same thing. So this ensures that question two we have solved it correctly. We have write a recursive Java method. Public static Boolean is palindrome that accepts a string and two integers as parameters. So let's copy that into our VS Code right here. And it returns true if the given string S is a palindrome and false otherwise. And we can't use any loops or library methods such as reverse. Ignore capitalization, treat uppercase and lowercase letters as equal. So a reminder of is palindrome is when we have the first so we have the word read exactly the same even when reversed. So for example, we have Bob or or like ABBA. So these two words are palindromes. However, even if it was this is case insensitive. So this also is a palindrome. So let us get started. A reminder, it should be recursive. So when writing a recursive program, we should think of a base case. So if something, we should return we should return. Okay. We have an int start int end. Let's think how this will work. So I'm thinking that the since we are comparing is palindrome, so the first letter should be equal to the last letter, and the second letter should be equal to the second to last letter. So if we compare them like that, and when we reach the middle, so when end so start is increasing and end is decreasing. Okay, so let us actually keep the base case until the end, and let us write the actual code. So we have if the first letter and the last letter, let's say if A and B, okay? If A was not equal to B, directly return false, right? Since whenever we have two, like let's say if we have the first letter and the last letter that aren't the same, directly return false. No need to for us to complete the recursive calls. Else we don't have to write else since we have return. So else we what we should do is return is palindrome. So we are calling it again on the same string. However, the start we are incrementing it by one, and the end we are decrementing it by one as we said. Okay, so this is the code. The base case is if we have end is less than or equal to start. So if start is more than or equal to end. Uh, when we have that, there's no need for us to complete since we checked the string from start till the middle and from the last till the middle, and they were equal. So here the base case is start more than or equal to end. What we should return if we reach that case, return true directly, since there were no uh, two letters that should be equal but weren't equal. Okay, what are A and B? A is simply a character, which is the s dot char at start, and same thing for B, and instead of start we have end. But here we have a small detail since they told us ignore capitalization, so it is case insensitive. So here it should be we should cast this to lowercase, either both to lowercase or both to uppercase. So we can use character dot to lowercase, and we pass down as dot char at start as parameter. Same thing right here. So this was the program, pretty simple. Um, all we should do is think of how are the recursive calls, and of course the base case. Of course, a pen and paper helps a lot, in especially in those recursive problems. So this was question 3. So this is a test for question 3 before we go into question 4. It should return true, false, true, true, true. Let us run it. So it runs just fine. So question 3 is correct. Okay. Now we move on to question 4, which is probably the longest, at least to read. Uh, it is a nice exercise. So let's start with it. A degree n polynomial is an expression defined by a list of n plus 1 coefficients as follows. So here we have a0 plus a1 times x plus a2 times x power 2 until we reach n. So for example, 2 plus 6x plus 2x power 3 plus x power 4 is a polynomial of degree 4. We should implement a Java program to represent and manipulate polynomials. So how are they stored? They are represented as an array where the index of the array represents the exponent and the value at the index represents the coefficient. So this polynomial right here is represented in this way in code. So it is an array where 2 is the coefficient of x power 0, 6 is the coefficient of x power 1. Since there is no x power 2, the coefficient is 0. And here we can see the rest as well. Okay, so we have two tasks. The first one is to implement print polynomial that takes an integer array and returns a string representation. And the other is multiply. Okay, so this is an example for print polynomial. And we take A and we should return this. So let's actually start with that before moving on to multiply. So we have public static, it returns a string, so string print polynomial, and we have integer array, I will call it poly. First of all, we have the string that we want to return. So I will call it result. It starts empty. Then we have, of course, we want to loop over that array. So for int I equals 0, I less than poly dot length and I plus plus. Okay, so let's have poly at I equal to n. So int n equal poly at I. So let's take further examination on the principles we need to print. First of all, we have the coefficients. We are printing them normally, unless let us actually start writing. So if um, if the coefficient or n was equal to 0, just skip. Okay. Here also we notice if n was equal to 1, also we skip. So if n equal to 1, skip. But what if 1 was equal 1 was at coefficient 0? So of course we can't skip that. It actually changes the whole polynomial. So if n equal 1 and the exponent is equal to 0, just skip, okay? So instead of exponent, we can say I, since at index I, the exponent, since I is the same as the exponent. So at exponent 0 is the same I equals 0, okay? Um, this is regarding the coefficients. Regarding printing the x, so if the exponent or I equals 0, just do nothing. As we can see right here, we are printing nothing. If I was equal to 1, just print only x. And if I is more than 1, so else print um, print x power and the exponent. Okay, so let us actually start coding. Now coding is very easy. We are just doing these steps. So let's start with skipping. You know, let's add an if statement. If n is equal to 0, skip. Or if n is equal to 1 and I is equal to 0, also skip or continue. Okay, this is regarding skipping, so we can remove those. Um, let me take a step back. So n is equal to 1 and I is equal to 0, skip. Actually, and I is not equal to 0, since if 1 is here, we do not want to skip it. So this was a mistake from me. Okay, so we finished these. Regarding x, before that, we have result plus equal, and in all other cases, we want to add the coefficient in the string. Regarding x, we need if I is equal to 0, do nothing. Okay, so I will literally do nothing in code as well. If I is equal to 1, print x. So if I is equal to 1, result plus equal x, else if I is more than 1, result plus equal x power, and we have here concatenated with the exponent. Okay, so this is the polynomial. We are still missing something, which is the plus operator here. So we add result plus equal the plus operator. Okay, so if we do that, we have plus here and plus after every term, but we will have plus here as well. So we can easily fix that by an if statement, since we are looping until we reach poly dot length. So if I is less than poly dot length minus 1, what we want to do is uh, to add the plus sign. Okay, and after we finish all that, we return the result. Okay. This was the printing. It was a nice exercise. Now we should move on to multiplying. Okay, moving on to multiplying, uh, implement a method multiply that takes two polynomials and multiplies them, returns an array of integers representing the resulting polynomial. Notes the product of two polynomials is obtained by adding the product of every term of the first one by every term of the second one. And the product of two terms involves multiplying their coefficients and adding their degrees. Okay, so the degree of the resulting polynomials is the sum of the degrees of the two highest exponents. Okay, so before I continue into the example, let us actually write a boilerplate. So public static, it returns an integer array and it is multiplied. Okay, and it also takes an integer array, also polynomial. Okay, so what will be this result? Um what is the size of it? Okay, so the degree of the resulting polynomial is the sum of the degrees of the two highest exponents. So here, for example, let's say 2 and 4 are the highest exponents. The highest degree will become 6. Okay, so if the highest degree is 6, then we have here 6 plus 1 slots or 7. So here we have 2 plus 1, and here oh sorry, here we have uh, two polynomials, so P1 and P2. So let's say here we have this has three, the length is 3, and here the length is 5, so 3 plus 5 is 8, but we only need 7. So this is the simple relation, P1 dot length plus P2 dot length minus 1. We can make sure this is correct through another example as well. Um, so this is the result. Now, what we need to actually grasp is how two polynomials are multiplied. So here, the two terms involves multiplying their coefficient and adding their degrees, and every single coefficient right here is multiplied by every single coefficient right here. So 1 times 2, 1 times 3. And here we have 2 times 2 and 2 times 3. The for loop. So for int I equals 0, I less than. Okay, so I less than what? So here we have P1 and P2. We are multiplying every single coefficient in P1 and every single coefficient in P2. So we have to loop through 1, then 2, then 3. So P1 dot length and I plus plus. And after that, we have int j equals 0. J is less than what? Here we let's say we selected 1, then we have to loop over these. We selected 2, then we have to loop over these. So P2 dot length and j plus plus. And here it is fairly simple. We are doing one thing only, which is p1 at I times p2 at j. Okay, the thing here is where exactly are we storing this relation? So, where are we storing every single one of these in the result array? So, let's go back to this example. The product of two terms involves multiplying their coefficients and adding their degrees. So, let's say we have I0 and J0. So, it will be resulted in x power 0. So, as if we have nothing. So, here it will stay 2 without an exponent. Here we have degree 0 and degree 1. So the sum of them is 1. So here we have it 3x. Okay, so the relation is result at I plus j. Okay, equal to p1 times p2, p1 at I times p2 at j. Notice here if we have 1 plus 0, or here we have 0 plus, so here we have 0 plus 1 or 1 plus 0. They both will be added to the result at I plus j, but one will override the other. So what we should do here is have plus equal. So we are adding over it. Okay. This was the multiply. It was simple, just we need to crack some things, and we had some hints here to help us. So here we should return the result. Okay, and by this we have finished question 4. Let's hope everything is correct. This is the expected output, and it is exactly like the expected output. And with that, question 4 comes to an end, and the quiz 2 revision session also comes to an end. We covered almost everything regarding 2D arrays, regarding file and input-output, regarding array lists, and regarding recursion, and of course this beautiful exercise. Um, I hope you do well in your exam, and thank you for watching.